This is Mr. Beck Does Your Homework. This is physics homework number 6, question number 1. Free fall problem. It says a robot probe drops a camera off the rim of a 354 meter high cliff on Mars where the free fall acceleration is 3.7 meters per second squared. Find the velocity with which it hits the ground. So what we have here is a robot probe on a cliff. So here's a cliff and here's my little Curiosity rover hanging out here. And he's got his robot arm out there and he's got a camera. So he's going to drop the camera off the rim of a 354 meter high cliff. So I know that this distance is going to be 354 meters, where the free fall acceleration is 3.7 meters per second squared. So let me start identifying some variables here. A robot probe drops a camera. When I drop something, I say that my initial velocity is 0 meters per second. Off the rim of a 354 meter high cliff. Now what's going to happen to the camera is it's going to fall 354 meters before it hits the ground. So I know that my vertical displacement is going to wind up to be negative 354 meters. It's going to go down 354. Where the free fall acceleration, that's g for Mars, but it's not 9.8 here, it's 3.7 because Mars is a different planet than Earth. So the free fall acceleration is 3.7 meters per second squared. So my acceleration is going to be the gravitational acceleration on Mars is in a negative direction, 3.7 meters per second squared because it's going down. Find the velocity with which it hits the ground. So my velocity is going to be what I'm looking for. So I've got a final velocity, I have a displacement, I have an acceleration, a final velocity, this was my initial velocity. Do I have an equation that relates those four? I sure do. My final velocity squared equals my initial velocity squared plus twice my gravitational acceleration times my displacement. You could have 2ax, but I'm using 2gy. So this acceleration is going to be g for Mars. So my final velocity squared is what I'm looking for. My initial velocity is 0, so that doesn't even matter when I square it, plus twice my acceleration is negative 3.7, and my distance I travel is negative 354. So luckily that negative and that negative will cancel out, making this positive. So when I find the square root, I'm going to get the square root of 2 times negative 3.7 times negative 354, and that's going to give me my answer for part 1 for question 1. Now question 2 says find the time required for the camera to reach the ground. If I want the time required for the camera to reach the ground, now I've got a final velocity, so I can really use any equation I want to solve for this. What I like to do sometimes is, let's use this one. My distance is going to be my average velocity. So 1/2 v0 plus v times t. Now v0 was 0, so that's going to go away. So if I want my time, let me multiply by 2. So that's 2y equals my final velocity times my time. So if I have 2y divided by my final velocity, that's going to be the time. But that's only because this one went away. So in this case, take your final velocity from here, twice your displacement divided by your final velocity. That will give you your time for it to reach the ground.